another Leetcode 150 problem. So the problem name is Koko Eating Bananas. Koko loves to eat bananas. There are n piles of bananas, the ith pile of which has piles of I bananas. The guards have gone and will come back in h hours. Koko can decide a bananas per hour eating speed of k. Each hour, she chooses some pile of bananas and eats k bananas from that pile. If the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. Coco likes to eat slowly but still wants to finish eating all the bananas before the guards return. Return the minimum integer k such that she can eat all the bananas within h hours. So in order to solve this problem, the approach that will be used is binary search. Basically, we'll do a binary search on the answer. So we know like we have to initialize two variables, right? The limits, the range of the possibilities of answers, and this will be the max of piles, max value in piles, right? So initially it would be 11, right? And mid value would come out to be 11 minus 1 is 10, by 2 is 5, so 1 plus 5 is 6, right? So let's check with 6 bananas per hour eating speed. Is it possible? How much time would it take to complete all the piles? So that can be taken by basically doing uh, a loop over the piles array, and just for each element dividing it with this mid value, then taking a ceiling over that value will give the number of hours that are needed to complete that pile, and then we sum over all the piles to get the total time. So 3 by 6 is 0.5 and ceiling will be 1. I mean 6 by 6 1, right? And then 7 by 6 and ceiling is 2, and then 11 by 6 and ceiling of that will be 2. So 2 plus 2 plus 2 is 6, which is less than 8. So definitely it's possible to complete all the piles. So we will initialize that we have found one answer, which is 6, right? So now we can look for lesser values also, right? So we'll do L equals to 1 and R equals to mid minus 1. So mid was 6, so R will be 5. Now let's calculate the mid. Will be equals to n plus 5 minus 1 is 4, by 2 is 2, plus 1 is 3, right? So mid is 3. Then let's check with 3. What is the amount of time needed? 3 by 3 is 1, 6 by 3 is 2, then 7 by 3 and ceiling will be 3, right? And 11 by 3 and ceiling will be 4, right? So 1 plus 2 plus 3 6 plus 4 10, which is greater than 8. So it's not possible with the speed of 3. So what we'll do is we'll do L equals to mid plus 1 is equals to 4 and R will be 5. Now mid will be equals to what? 5. This will be 4, I think. Yeah. So mid will be 4 plus 5 minus 4 is 1, by 2 0. So mid will be 4. So let's check with 4. 3 by 4, 6 by 4, so ceiling 2, 7 by 4, 11 by 4. So this will be 3. So 1 plus 2 3 plus 2 5 plus 3 8. So this is possible. After this we'll again keep a track that we found one answer, and then we try to look for lower one. So L will keep it 5, R will be equals to mid minus 1, right? So mid was 4, so 3, but now R is less than L, so we can break out and return the result. So let's code this approach up. So let mutable L equals to 1, let mutable R equals to, we'll find the max, so piles dot iter dot max dot unwrap, right? Now we'll do while L is less than or equals to R, and let's create a function. So basically let's copy this and is possible, and we will instead accept a borrowed variable, and we'll instead also have one extra which will be of type y32, right? And this will return a bool. So let's implement this. So for pile in piles we'll do something. Let's have a variable to calculate the hours needed, so initialize it with 0, and let's do I64 to avoid integer overflow. So let pile equals to pile as I64, right? And also do that for mid. Right, then what we need to do is need plus equals to, so pile plus mid minus 1, because we are trying to take a ceiling, so we'll use this calculation, right? And then we return need is less than or equals to h, whether this is true or not, as I64. Then we'll just use this function that we created, or method that we created, right? So our implementation, whatever the correct term is. So anyway, if self and is underscore possible, and let's pass piles h and mid. If this returns true, then we say res equals to mid, and we say r equals to mid minus 1. And let's also initialize let mutable res equals to 0. Then if this is not true, then we do L is equals to mid plus 1, and after doing this binary search we'll just return res. So let's try running this. Okay, I think I forgot to add mid equals to L plus R minus L by 2, right? So now let's try running. Okay, this is a typo. So let's try submitting the solution. As you can see, we have passed all the test cases. So thanks for watching.